Hello friends, welcome to my workbook. Very happy to meet you all with another video on logical reasoning. The topic for the day is counting of triangles. In exams, images like the ones in the screen will be given and we will be asked to find the total number of triangles in such images. In this video, I will be sharing with you some tips, tricks, and also shortcuts to solve such questions. I have covered many types which have been recently asked in all the competitive exams. With no further delay, let's get started. Let's begin with the most basic image, the one on the left side. There's just one triangle in this image. Now, here in this second image, a vertical line has been dropped from the peak to the base. How many triangles do you think are there in this image? There are two smaller triangles. 1 and 2 together they combine and form the bigger triangle. So totally there are 3 triangles in this image. Let's move on to the third image. Here there are two straight lines dropped from the peak to the base. We have to count the total number of triangles in this image. Let's first count the smaller triangles. There is 1, 2 and 3 small triangles within the bigger one. Then 1 and 2 together they combine to form a triangle. I will shade its boundary. As you can see, 1 and 2 together forms a triangle. So that is one more. Similarly, 2 and 3 together they will form another triangle. So another one. And 1, 2, 3 put together forms the bigger outermost triangle. So that is one more. Totally there are 3 plus 1 plus 1 plus 1, which is 6 triangles. So this image has 6 triangles. But do you think it's wise to count the triangles manually like this? Won't it be better to use some shortcut to quickly solve such questions? Definitely. I'll show you one such shortcut. Let's try solving this image here. As you can see, there are 1, 2, 3 lines dropped from the peak to the base. So instead of counting the triangles manually, we will use this shortcut. Take the line which acts as the base. It is this horizontal line, and mark the number of segments that it has been divided into. That is, this short line is one segment, so I number it as 1. Next segment, this is 2, and there is one more 3, and here it is 4. So I've just numbered the different segments into which the baseline has been divided. Just add these numbers, 1 plus 2 plus 3 plus 4. It will be 3, 6 and 10. So 10 is the total number of triangles that can be formed from this image. Simple, isn't it? Can we try this back in this third image here? As you can see, the base has been divided into 3 segments, 1, 2 and 3. So if we just add these 3 numbers, 1 plus 2, 3, 3 plus 3, 6, we get 6. So 6 is the total number of triangles in this image. Let's solve this image here. We need to find the total number of triangles in this image. Simply identify the baseline and mark the segments that it has been divided into. 1, 2, 3, 4, 5, 6, 7. And all you have to do is just add all these numbers. 1 plus 2, 3, 3 plus 3, 6, 6 plus 4, 10, 10 plus 5, 15, 15 plus 6 will be 21, 21 plus 7, 28. So 28 is the total number of triangles that can be found in this particular image. So using this shortcut, you will be able to solve this type of problems in very less time. Now let's move on to the next type. Here, like the previous images, there are vertical lines dropped from the peak to the base, And also there are one or more horizontal lines within the triangle. So it's just the extension of the same shortcut. Identify the baseline of the triangles. Now this line at the bottom is one of the base, and how many segments is it divided into? 1, 2, 3. So on this base there will be 1 plus 2 plus 3, that is 6 triangles formed. Similarly, there is one more line which can act as the base, the one here. This also has been divided into many segments. How many? 1, 2, 3. So with this base, the total number of triangles will be 1 plus 2, 3, 3 plus 3, 6. So totally in this figure as a whole, there will be 6 plus 6. That is 12 triangles in this image. Can we move on to the next one now? Let's first take up this bottom line. It is one of the bases and it has been divided into two segments, 1 and 2. So the total number of triangles with this line as base will be 1 plus 2, which is 3. Same way, this horizontal line is one possible base and it has been divided into 1, 2. So 1 plus 2, 3 triangles from this base. Here again, one horizontal line divided into two segments, and with this base there can be 3 possible triangles. So in this image as a whole, there will be 3 plus 3 plus 3, totally 9 triangles. Remember, the numbering should start from 1 for each line. It's 1, 2 for this line, and for the next line you start the numbering from 1. You do not continue it 1, 2, 3, 4, 5, 6. That is wrong. So next image is this one here. The bottom line is a base, and let's count the number of segments. 1, 2, 3, 4, 5 and 6. So 6 different segments in this base. So if we add up all these numbers from 1 to 6, we get 21. Let's move on to this line. This can also be base for some of the triangles. And how many segments are there? 1, 2, 3. So 1 plus 2 plus 3 will give you 6. 6 possible triangles with this as baseline. And here it's a smaller line with two segments, 1, 2. So with this baseline, the total number of triangles is 1 plus 2, that is 3. So for the image as a whole, we need to add up all these numbers. 3 plus 6, 9, and 9 plus 21 will give you 30. So this image as a whole has 30 different triangles. So whenever you see straight lines dropped from the peak to the base and also some horizontal lines in between, you can use this shortcut. Let's move on to the second type. So let's count the number of triangles formed inside a square or a rectangle. Let's begin with the simple figure here. It's a square with two diagonals drawn inside. This is one triangle. Similarly, we have a second triangle here, third one here, and fourth one here. Is that all? No. 1 and 2 together will form a bigger triangle. Let me show the boundary. 1 and 2 together forms a triangle. So that's plus 1. Similarly, 2 and 3 together will form another triangle. And 3 and 4 together will form another triangle. And 4 and 1 will combine to form another triangle. So totally there are 8 triangles in this image. Again, it's not wise in a competitive exam to sit and count the number of triangles manually. It's always better to practice with some shortcut. And here for this type, the shortcut is just number the smaller triangles that you see inside the square. This is 1, 2, 3, and 4. There are 4 smaller triangles inside this square. Now multiply that total number of smaller triangles into 2. 4 into 2 gives you 8. So 8 is the correct answer. Let's move on to the second problem. It's of the same type. You see there is a rectangle and diagonals are drawn. Also lines parallel to the sides are drawn. So many small triangles are formed inside the rectangle. We have to find the total number of triangles. The shortcut is just number the smaller triangles that you see. 1, 2, 3, 4, 5, 6, 7, 8. Multiply the number with 2. So 16 is the total number of triangles found inside this rectangle. Clear? Let's move on to the third image. You can see that there are 2 squares within each other and the lines drawn inside cut both the squares into many parts. Let's take up the inner square first and number the smaller triangles. So there are 8 smaller triangles inside the inner square. So for the inner square you will have 8 into 2, which is 16 triangles. Now let's move on to the bigger square on the outside. The same straight lines have divided the interior of the square into many parts. Let's number the smaller triangles formed inside the bigger square. This is one smaller triangle formed, so we can number it as 1. Similarly, you have a second one here. Same way, you can see 8 triangles formed within the outer square as well. So for the outer square, there will be 8 into 2, 16 more triangles. So for the total image, you just add up the two numbers, 16 plus 16, it will be 32 triangles totally in this image. Let's move on to the next type. Here we have more squares joined with each other and each of the square has been divided by the diagonal. Let's use the same shortcut. Let's handle one square at a time. The first square here. How many smaller triangles are there? 4, isn't it? So total number of triangles will be 4 into 2, that is 8. Similarly, for the next square, there will be 8 more triangles. 4 into 2, 8. So within the two squares, you have 8 plus 8, 16 triangles. But what happens when we join such two squares together? There will be 2 new triangles formed. Let me mark them with green marker. So here, because of the two squares joining together, we have one triangle here and one more here. So we must not forget to count these two triangles as well. So because of this joint, there are 2 more triangles. So the total number of triangles will be 8 plus 8 plus 2. It will be 18. Let's move on to the second image here. There are 3 squares attached side to side. We already have seen that each square will have 8 triangles because there are 4 smaller triangles and we multiply the number of smaller triangles with 2. So this square will have 8 triangles, the next square will have 8 and the third one will also have 8. Now I have told you that for every joint there are 2 new triangles formed. So for this joint you need to add 2 and another joint here there will be 2 new triangles. Can you see? So for every joint we need to add 2 new triangles. For this joint I've added 1 and for this joint let me add 1 more. So the total number of triangles will be 8 plus 8 plus 8 plus 2 plus 2 and it would be 28. 28 is the total number of triangles in this image. Let's move on to this figure where there is a L-shaped joint. Each square will contribute 8 small triangles, correct? So there are 1, 2, 3, 4. So 4 into 8 will be 32 small triangles. Now how many joints are there? There's one joint here, one joint here, and one more joint here. So 3 joints. So you will add 2 triangles for each joint. So 3 into 2, that will be 6 triangles. Is that all? No. The big one in the right corner. This triangle is yet to be counted in. So that's one more triangle. So totally there will be 39 triangles in this figure. Let's move on to the last image of the slide. There are 4 squares in this image and they are connected to form a T-shaped figure. Each square will have 8 different triangles. So there are 4 squares. Totally there will be 4 into 8. 32 triangles from the 4 squares. Now let's move on to the joints. We have seen that for each joint there will be 2 new triangles formed. Let's count the number of joints in this image. This is one joint, this is second joint, and here there is the third joint. So 3 joints. So the number of triangles formed will be 3 into 2, 6. Apart from these, due to the T-shaped formation, there are 3 bigger triangles formed. So there are 3 bigger triangles formed due to the T-shaped formation. So let's add the 3 as well. So the total number of triangles will be 32 plus 6, 38 plus 3, 41. So this image has totally 41 triangles in them. Let's move on to the next type of images. Here you can see there are many triangles within a bigger triangle. It's almost similar to a prism to see. So let's count the number of triangles in these images. If we count manually, it's more time consuming and the results might not be accurate as well. So what is the solution? There is a formula which can be applied to get the result for such images alone. N into n plus 2 into 2n plus 1 by 8. So this will give you the total number of triangles in such kind of images. So what is n? N is the number of triangles along any side. Let's choose this base. How many triangles are based along this line? 1, 2 and 3, right? So n will be 3 for this image. And if we substitute n as 3 here, what will we get? 3 into 3 plus 2 is 5 into 2 3s are 6, 6 plus 1 7. So 7 divided by 8. This will give 3. This will give 13.125. We can drop the decimal portion and consider only the whole number. So the total number of triangles in this image is 13. Let's apply this formula for the second image. We have to determine the correct value for n. Let's choose this side of the triangle and see how many triangles are along them. 1, 2, 3, 4. So for this image, n is equal to 4. So if we substitute n as 4 in this formula, you will get 4 into 6 into 9 by 8 which will simplify to 27. So the number of triangles in this image is 27. Same formula can be used to find the answer for this image as well. In this image, what is n? N is 5, and if we use this formula, we get the answer as 48. Remember, if this formula gives a decimal answer, just consider the whole portion of it. The fractional part can be ignored. So that's the end of this video, my friends. We have seen counting of triangles for different types of images. Hope it was useful for you. Meet you soon with another learning video.